Assalamu alaikum everyone. I'm Karatulan from the Department of BS Biotechnology, and today I'm here to deliver a short and brief presentation on the topic of electronic configuration. First comes the definition. What is the definition of electronic configuration? Electronic configuration is the distribution of electrons of an atom or a molecule in atomic or molecular orbitals. Then comes the subshells, which are required for the electronic configuration. There are the four main subshells: S, P, D and F. S contains 2, P contains 6, D contains 10 and F contains 14 electrons. Moving on, there are three main principles. Three principles which we use for the distribution of electrons. Number 1, Aufbau principle. Two, Pauli's exclusion principle, and number third one is Hunds rule. The number 1 Aufbau principle states that in the ground state of an atom or an ion, electron fill atomic orbitals of the lowest available energy levels before occupying the higher levels. Means the 1s subshell should be filled first, then the 2s subshell, because the energy of the 2s subshell is higher than the 1s subshell. So containing the low energy, the 1s should be filled first, then the electron will go into the 2s subshell. It is the simplest way to understand the Aufbau principle. So it can be better understand with the help of the energy level diagram. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f. So according to energy levels, 1s should be filled first, then the 2s, then 2p, then 3s, then 3p, and then 4s. Before going to 3d, the electron will fill into the 4s because the energy level of the 3d is higher than the 4s. So 4s will be filled first, then 3d, then 4p, then 5s, like this. Then 4p, 5s, then 4d, 5p, and then the 4f, 5d, and at the last one the 5f. It is the basic structure of electron filling diagram, energy level diagram, for just understand. Our next rule is Pauli's exclusion principle. This rule states that it is important for two electrons residing in same orbital of the polyelectron atom to have the same values of 4 quantum numbers. Or simply we say that two electrons in same orbital should have opposite spin. If we take its example, for example hydrogen. Hydrogen has only one electron in its outermost shell, so it will be filled in the 1s lower energy level and with single spin because it has only one electron. If we talk about the lithium, because lithium has 3 electrons, so 1s, then 2s. So first, with the lower energy level, the electrons will be filled in the 1s, like this and like this. There are the 2 electrons, 3 electrons, so 2 will be filled in 1s because s contains 2 electrons but with opposite spins, not with the same spin, with the opposite spin. And then the leftover one single electron will move towards the 2s, the higher energy level, with single spin. This was the Pauli's exclusion principle. Then comes the third rule, which is the Hunds rule. This rule states that if the degenerate orbitals are available and more than one electron are to be placed in them, they should be placed in separate orbitals with the same spin rather than putting them with the opposite spin. So this is the interesting rule. Let us take an example of carbon, which has 6 electrons in its outermost shell, and they will be filled just like that: 1s, 2s and 2p. 1s2, 2s2 and 2p2. All the 6 electrons are filled according to the energy levels. Then now this is the complete degenerate orbital. This is also the complete orbital. Now moving on to the P is a subshell which further contains its degenerate orbitals, that is px, py and pz, and all contains the 2 electrons, which collectively leads to the accommodation of 6 electrons into the p orbital or p subshell. So here are 2 electrons only in the p orbital. So it is necessary to know that the electrons will fill in these degenerate orbitals singly with the single spin. So as in carbon there are the 2 electrons, so it will be filled just like this and this, not like this that both 2 electrons are filled with opposite spin into the same degenerate orbital, which is the x1. No, the with single spin when with different degenerate orbitals, and this is the correct way of distribution of electrons. So this was all about the electronic configuration. That's all from my side. Thank you.